Şimdi durmadan lafını ediyor. We have been saying many times that initial conditions are important. It determines your solution. So what is that initial condition? How we are going to set that initial condition? That's the question now. Because when the circuit given to us, initial conditions are also given to us. How we set that initial condition to that value is not clear. So in here, I would be explaining to you how this is set. So let's consider this circuit here. That circuit helps us to set an initial condition for a capacitor like that. And this is also going to be done in lab. That's why it helps you to understand the lab session as well. So let's go to this in the board now. That's the same here. If you look at this switch here, that switch is the red switch is in the left hand side. So the circuit is this is now. So if we keep this switch on this left hand side, that means that B position for a long time, that means the transient solution has disappeared. So what we are going to observe is the particular solution. Particular solution is the solution that we observe, that is the same type of source. So I'm looking in this circuit now. When the switch is on the left hand side, I'm looking for particular solution. Particular solution. While Vs is equal 50 volts. So if it is particular solution, it's going to be the same form of source function. So particular solution is going to be, in this case, since there's a capacitor here, the state variable is Vc. Vc particular is going to be a constant. Particular solution in the same form of the source, therefore particular solution is going to be a constant. So how I'm going to calculate this constant? It is particular solution, we said. Then I can use the definition relation of a capacitor, which is Vic is C times dVc over dt. Since this is constant, derivative of it gives you 0, then from that I can say that IC is equal to 0. That is open circuit. So this is open circuit then. So if you consider the left hand side, so I'm talking about this now. Should I redraw it? Yes, I could do that. Resistor, and after the connection, that is the capacitor, and we calculate this capacitor is open circuit. That means that IC current is equal to 0. So that means resistor current is also 0, isn't it? Because if you write the Kirchhoff current law equation for this node, this current is equal to this one. On the other hand, they are serially connected, so serially connected elements currents are the same. So this is also 0. IR equals 0. If IR equal to 0, then VR equal to 0. Definition relation. V is R time I. If this is 0, then this is 0. If this voltage is 0, this open circuit voltage, that's open circuit. Open circuit means this, isn't it? No current, so this is open. So this voltage is going to be same as source voltage. Why is that? Because this voltage is 0, then the voltage between those two, since this is short circuit, is going to be 50. So particular solution is 50 volts. So what I have done here, there is a 50 volts voltage on that capacitor. As soon as I transfer this switch from left hand side to the right hand side, the circuit is going to be like that. And this is going to be the initial condition VC 0, 50 volts. 0, assume that 0 is the time that we transfer this switch from position B to A. So then it's going to be VC0 is equal to 50 volts. That's the initial condition. Initial condition for this circuit. So I set the initial condition to 50 volts. This is what I have done. So if you find the current here, it's going to be the natural solution. So IC is going to be natural solution. Why it is natural? Because there is no any other source. The only energy source is coming from that initial condition. That energy is 1 over 2 C VC 0 square. That's the energy. So we are using that energy. I know that this energy is going to disappear after a few seconds. So you're going to observe all that in the lab. So what we have done, I use this circuit now and this switch to have an initial condition on a capacitor like that. If you don't use that, as soon as you move that switch to the left hand side, you assume that there is no resistor in here, so that means you set the capacitor initial condition to 50 volts. This is how we set the initial condition for a capacitor. So end of the video.